So when you have a product of trigonometric functions, such as the one we have here on the screen, you don't have to do anything new to handle this, but you do have to kind of combine a few older techniques. Let me just show you by example. So in this case, we have this product, sine and cosine. And what's important when you have products of sines and cosines is finding a power that's odd. Okay, and so in this case we have this odd power here, 3 on the sine. And so the technique for dealing with this situation is to start by isolating one of those signs. So I'm going to rewrite this as I'll take one of those signs. So I'll have 2 left over. And I'll stick that sign here next to the differential d theta, and I'll explain what I mean, why I need that in just a second. First things first, we're going to want to turn everything else into cosine. So let me annotate this. So if we have this sine of theta d theta, and the important thing here is we have sine isolated here, we want only cosine. That's all we want to have left over here. And you'll see why that works out in just a second. In the meantime, how the heck would we even get away with that? Well, I can use this trick here. I remember that sine squared of theta plus cosine squared of theta is equal to 1. So if I want to get rid of my sine squared here, or any power of sine squared, like sine to the 4th, sine to the 6th, I could just solve for sine squared. So sine squared of theta is 1 minus cosine squared of theta. And that's the identity that we're going to want to use. We're going to take that and plug in. And while I'm doing this, notice that each time I'm rewriting this integral sign and this d theta, because I haven't actually taken an integral yet. I'm just doing a little bit of trig. So let's go ahead and make that change. So I have integral, instead of sine squared here, I'll have 1 minus cosine squared of theta, cosine to the 4th of theta. I still have this sine of theta d theta, and as I promised, I'm gonna deal with that. It's not gonna be too bad. I want to note that I do have only cosine now, and then I have my sine of theta d theta. Okay. So if you have the sine theta d theta, you want only cosines everywhere else. And why would I do that? Well, that's where substitution comes in. So what I will do here is, because I have just the sine theta d theta here, I can let my u equal, I don't want to equal sine, I want to get sine when I take the derivative of u. So cosine of theta d theta, so my du is negative sine of theta d theta. Well, there's a negative there though. I don't have a negative up here. No problem. Just hit both sides with a -1, and that'll take care of it. So let's rewrite. So on the only cosine stuff, the bulk of what we're dealing with, I can replace every cosine with a u. So let's do that. 1 minus, instead of cosine, I have u squared, u to the 4th, and instead of sine of theta d theta, I'm going to have a negative du. All right, so I'll multiply out that negative to get u squared minus 1, u to the 4th du. I'm just taking that negative and hitting this and that with it. So the u squared becomes positive, 1 becomes negative, and then I can multiply out u to the 4th du. And good news, I can integrate that. That's just a simple reverse power rule. If I integrate u to the 6th, I get u to the 7th with a 1/7 minus u to the 5th over 5 plus c. Now it's tempting to stick a box around that, call yourself done, but remember what the actual question is. Something to do with sines and thetas and cosines and thetas. What are these u things? Well, I made those u's up. Just a couple moments ago, I made those u's up. And so I can't just give an answer that has to do with a made up letter u. All right, so I'm not done, but I'm pretty close because what is u? U is just, oh, so I apologize. You probably saw the error and were screaming at me. I don't need a d theta there. I haven't taken the derivative yet. The d theta shows up once you take the derivative of both sides. I apologize for that. So now that that's been corrected, we see that, okay, u is just cosine. So all I have to do is replace all these u's with cosines. Cosine to the 7th of theta minus 1/5 cosine to the 5th of theta plus c. And that is my final answer. And if you don't believe me, well, we can always check our work. Whenever we do an integration problem, we'll check it by just taking the derivative of our answer. Okay, well, first of all, constant goes away when you take the derivative. Everything else, we take the 7 down, it cancels with the 1/7, leaving me with cosine to the 6th of theta. But don't forget we have a sine to pop out because of the chain rule. Minus 1/5 cancels with the 5, leaving me cosine to the 4th. But a sine pops out because of the chain rule. What's the other thing I'm forgetting? Well, it's not sine that pops out. The derivative of cosine is negative sine. So negatives pop out of both as well. And, well, what do I do from here? I can factor some stuff out. I see I've got cosine to the 4th of theta, sine of theta in both terms, leaving me with a 1 minus cosine squared of theta. But what's 1 minus cosine squared? Just a moment ago we said that was sine squared. So we have to do a little bit of trig to get there, but I do end up with cosine 4th sine cubed of theta. And if we go way back to the beginning of the problem, sine cubed cosine 4th sine cubed, when I take the derivative of my answer here, I do get the thing that I originally integrated, so I did find the general antiderivative, which is what I wanted. All right, let's take a look at another problem. All right, so now we have a similar situation, but instead we have an odd power on cosine, which means we're going to do the exact opposite of everything we just did, basically. So what did I do last time? I isolated one of the odd power signs. All right, this time I'm going to isolate a cosine. So rewrite that as such, cosine to the 4th, 2y, and I'll isolate a cosine of 2y dy. Okay, so just like before, I've got a cosine next to my differential here at the side, which means that since I have a cosine here, I only want sine. Okay, well that's a problem because I have these cosines right here. So what am I going to do? I'm going to do the exact same trick. And I can always start with this well-known, drilled into my head for a long time identity. Sine squared plus cosine squared is equal to 1. But if I want to get rid of cosines, I'll have to solve for cosine. Cosine squared is 1 minus sine squared. All right. So, well, hold on. I've got thetas here. I could have had x's, but I have y's in the original problem. That's no big deal because theta could represent any real number, so that's also true for 2y. So I don't need to let that freak me out. All right, good deal. So now I need to rewrite the original. Oh, well, shoot, I've got cosine to the 4th here. Okay, well, that's also not going to be a problem. Cosine to the 4th is just the square of cosine squared, so I just want the square of this sine term here. All right, so what does that leave me with? Sine squared 2y, quantity 1 minus sine squared of 2y all squared. I still have cosine of 2y dy. Good deal. Take a second, make sure that works for you. I've got the cosine to the fourth here. I found cosine squared here, but to get to the fourth, I had to square my expression. All right, so now that I'm here, what's the deal? Well, I need to do the opposite of what I did last time. Last time, I let u equal cosine. Here, I'm going to let u equal sine. Well, it needs to be of 2y, though, because that's what this problem deals with. U is sine of 2y. That means my du is 2, because the 2 pops out because of the chain rule, cosine of 2y. Now, I don't have any 2's over here. I just have cosine of 2y, so I'll just make that 1/2 du cosine of 2y. And that works well enough. So let's plug everything in. And all my sines of 2y's become u's. So here I have a u squared, 1 minus sine squared again, so u squared, all squared. And then the cosine of 2y here becomes 1/2 du. So I'm going to need to do some algebra now. So let's see, I can bring that 1/2 out to the very front. I can bring it all the way to the outside if I want. U squared, let's square this binomial out. That's going to be 1 minus 2u squared plus u to the fourth using my binomial formula. Or you could FOIL it out if you want over here on the side. But in any case, that's what you'll end up with. And then I'll just multiply all this u squared stuff out, giving me u squared minus 2u to the fourth plus u to the sixth du. Okie doke. Now I can integrate u cubed with a 1/3. The 2 comes down. U to the fifth means we divide by 5. 1/7 u to the 7 plus c. Don't be tempted to just multiply out that 1/2 because I made up u. U is this made up thing. I need to put it back in terms of the stuff the question actually cares about, which is sine, cosine, and 2y. So in this case, my u is equal to sine here. So I'll replace that with 1/2, 1/3 sine cubed of 2y, not theta. Need to be careful there. 2/5 sine fifth 2y, 1/7 sine seventh 2y, all that plus c. And that's a final answer right there. Of course, if you want, you can multiply out that 1/2, get 1/6. The 1/2 cancels with the 2, leaving me with 1/5 and 1/14. All right, and that is also a good final answer right there.